Okay, now let's look at the first. We are going to introducing our two models in this lecture, the linear probability model and the logistic regression model. But before we start, we want to introduce in this case, the main reason is to show you why the regression model we cover at this point cannot address the problem like we're using here. Okay, electronic mail, email. So maybe a lot of students didn't even know what email stands for. It stands for electronic mail. It's one of the most widely used internet services. While emails can greatly benefit productivity, they are acceptable to unsolicited, unwanted, and possibly virus-infected spam message from illegitimate email addresses. Peter Derby works as a cybersecurity analyst at a private equity firm. His colleagues at the firm have been overwhelmed by large-scale spam emails. So Peter would like to implement an effective spam detection system on the company's email server, and he has been tasked to create spam filter that detect spam email and stop them from getting into email boxes. Okay, as you can see, the data set he collected. And so he analyzed a sample 500 spam and legitimate emails. So basically, among these emails, some of them are spam and some of them are legit emails, which are not spam. So as you can see on the screen, there is we cannot show all 50 data. So I'm just showing the 3 from this 50 data. So basically on Excel sheet, you will be able to see this 5-column data. In the total, you will have 501 rows because the first row is the label. And so when they collect the data for those 500 emails, first of all, they had a record. So basically, hey, this is the first email, second email, etc. So the first column doesn't mean anything in your model. It just literally let you know, hey, those are my elements. I have 500 elements here. Now let's look at the first email. And for the first email, it's characterized by whether they are spam or not, whether how many recipients received that email, whether they have hyperlink in the email, and then also how many characters in that email. Okay, how many letters in that email, including the spaces. Okay, so basically those 4 columns are used to characterize each email. So now as you look at all 4 columns, which one going to be my dependent variable? And you will notice the dependent variable actually is a column called the spam. So that is indicator. Basically, if it's 0, that's a spam. 1 gonna be, if it's 1, it's a spam. 0 it is not spam. And so they are thinking maybe the number of the recipients, whether how many hyperlinks they have, and how many characters they have, will be a predictor to help you to predict whether the email is a spam or not. Okay, so basically, dependent variable is a spam column. Independent variable including recipient, hyperlink, characters. So now, the question here is, you notice the difference between what we already learned versus this example, right? My dependent variable, it is no longer quantitative data. Remember before we talk about the salaries, predicting salary, etc. So the Y variable always going to be a quantitative data. But as you can see here, whether the email is a spam or not is no longer quantitative data. It is a category data. We use the numeric value 0 and 1 to indicating whether it's a spam or not spam. Okay, so this is when you know the regression model we learned before might not be our best choice. Instead, we are considering use logistic regression. Again, in this video, we're also introducing the traditional regression model. It might still be able to work, but you need to know what you are predicting about your Y. Okay, so let's think about this dependent variable. 0 or 1, right? So although it's a 0 and a 1, but on the other way, we can think about it, it is a probability, right? Given we know the email is 100% going to be spam, so therefore the probability for the second email spam is 100%. So as you are thinking 0 and 1 scenario, it actually can consider as a continual probability, right? It is from 0% to 100%. If it's a spam, not spam, we know if we see the email is not spam, the probability for that email be spam is 0%. So therefore, when we are predicting my dependent variable here, we can considering it's not just about predicting 0, 1. It's predicting what is the probability that email gonna be a spam. Okay, so now we are very smartly to converting 0, 1, which is categorical data, into this continual variable, which is my probability. So that is very important information to know. First, when you need to consider use logistic regression, when your dependent variable, like here span, is a categorical data, that's when you need to consider use the logistic regression. And the second, whatever you predict at the end about that y hat, it is gonna be a probability. Okay, probability. Okay. So before we move on to going further, I want to give you a few more examples that you can think about when you need to use a logistic regression model. Okay, so for instance, when you as a company to detect who's gonna leave the company, whether the person gonna leave or stay in the company, as a manager, right, you always want to make sure to know, hey, somebody gonna quit, and so you can start to hiring so that you don't end up missing the key performer on your team. So in that situation, you also need to use logistic regression to predict which employee are more likely to leave you, right? So that's another example that you think, hey, I need to use logistic regression versus just the regression model itself. Okay, you can think about many, many other examples. The key here is your dependent variable going to be a binary, like you only have 2 outcomes, just like your binomial distribution, right? And then you try to understand for these 2 outcomes, which one using the model to predict which outcome more likely be happening. Okay, so now here's the question: develop a logistic regression model for spam detection. So you can imagine if we are able to use, have some kind of model based on these 3 columns information to know whether they're going to be a spam or not, that become a magical model, right? So instead of going through each email, now we can just based on the number of recipient in the email, the number of hyperlink, and how many characters in that to flagging the email, right? So the likelihood that email going to be a spam. Okay, and the second is assess the performance of the estimated model, and then the last one is make a spam prediction for specific predicting variable values. Okay, so we try to achieve all the 3 goals. Okay, so first, like I said, I already spent a lot of time to emphasize when you need to consider using the logistic regression, and here we'll also introduce another model which is really related to what I already learned, called a linear probability regression model. Okay, so the key here is my dependent variable is a categorical binary outcomes. So if the outcome is more than 1, and you cannot use the logistic regression or linear probability model, you need to consider another one that we will not cover in here, or be in more advanced modeling class. So the model we call the multinomial regression model. Okay, multinomial regression model. So that is nothing we are going to cover in this class, but just keep in mind to use binary logistic regression, you need to double check your dependent variable. First has to be categorical. Second, for this categorical data, you only have 2 possible outcomes. Okay. So now let's first starting exploring the linear probability model. So for the linear probability model, it just looks like our linear regression model. And then so the thing here is that you need to know the output you are predicting that y is no longer is y, is the probability. Okay, going to be a probability. So for the linear probability model, we also call it LMP. So nothing you need to change when you're thinking about linear probability model. The only thing you need to think about is the predicted value for the y hat is become the probability. So in the using the previous example is that the probability that email will be a spam. Okay. So let's look at another example here. Use this example to look at the linear probability model. Okay, so an environmentalist wishes to investigate the relationship between exposure to air pollution and the likelihood of developing respiratory illness. Okay, think about likelihood of developing, having or not having this illness, right? So therefore, it's a binary outcomes. So that's when you're thinking, you can use either linear probability regression model or logistic regression model. So therefore, this scientists surveyed 220 individuals living in the city with a high air pollution level. For each individual, the data are collected on the daily average number of the minutes spent outdoor without a mask, and whether the individual has diagnosed with a respiratory illness over the course of a year. Okay, so therefore, they are building a very simple model. So in this model, they only had one dependent variable, which is the daily average number of the minutes spent outdoor without the mask. Okay, so the dependent variable, that is the one we try to predict, is whether this person diagnosed or not diagnosed with the illness. If they diagnose with the illnesses, well, the value for y will be equal to 1. If it does not diagnose with this respiratory illnesses, the y value will be 0. So therefore, we can just use Excel to estimate this equation. Illness equal to beta 0 plus beta 1 times the minutes the person going outside without mask, and plus our error term. So this is the model we try to estimate. And then the second question is, predict the respiratory illness probability for an individual who spent an average of 8 hours. Okay, so it's 8 hours. You need to convert 8 hours to the minutes before you plug into this equation. You estimate it. Okay, so let's look at the answer together. So the main goal here is, again, show you the similarity between linear probability model with what we already learned. Second is show you the weakness of this model. And then you will know why we need to consider use the logistic regression model in this situation. Why logistic regression model are better than the linear probability regression model. Okay, look. This is the statistic result. So this is the third table you are able to obtain on a regression Excel output. Okay, so the y-intercept, negative 0.1291. The p-value is 0.043. And then the slope, the partial coefficient for minutes is 0.0011. And the p-value is 0.000, so smaller than the threshold, 0.05. So therefore, the number of the minutes outdoor without mask has a statistically relationship with whether the person developing a respiratory illness or not. Okay, so the relationship is significant. And then, so basically, if you're interpreting 0.0011, that means if a person stay 1 more minute outdoor, the probability for this person to gain this respiratory illness will increase. The probability will increase by 0.0011. Okay, so that's a probability increase almost nothing, I guess. Okay, now after you have this relationship between the probability of the person getting these illnesses with the time they spend outdoor without mask, so then we can address the second question, that is, if this person spend outside 8 hours, what is the chance this person gonna developing the respiratory illnesses. So what we did is, first of all, we convert 8 hours to minutes because everything's measured by minutes. So 8 hours times 60 give you 480 minutes. So therefore, we'll plug in this equation and we get a value equal to 0.3838. Okay, so therefore, for this person, if they spend 8 hours on average outdoor without mask, the probability for this person developing the respiratory illnesses are 83.38%. Okay, that's good. But here we want to talk about the weakness of this problem, of this model. So how about instead of 8 hours, how about this person stay outside for 20 hours? So if you convert 20 to minutes, it gives you 1,200 minutes. And then you plug in this model, instead of the number below than 1, you will get 1.1531. So basically this saying, if the person stay outdoor for 20 hours, and the probability for this person gain the respiratory illnesses become 1.5, so 150%. So the probability is 115%. As we learned probability before in your QBA2, you know that the probability value can never larger than 1, right? So that is what we are seeing here is the weakness of this model. Okay, so the weakness for this model, for the linear probability regression model, is that you will end up the predicted probability either larger than 1 or can also become negative territory that does not satisfy the requirement to the probability. So therefore, when we are facing the binary outcome that you are predicting the probability, this linear probability model is not the best choice because it will generating the nonsense predicted outcomes. Like here we show you 20 hours, you end up probably larger than 1. So that is not what we are looking for. So that's why when we are thinking about how can we predicting the binary dependent variables probability, we need to turn into logistic regression. Okay, so that is what I'm going to talk about, our logistic regression.